Hello and welcome. My name is Robert, and today we are going to jump into HTTP in detail as I continue on the Tryhackme platform down the Comptia Pentest Plus learning path. So I just made it into attacks and exploits at some time in the past. I did this room, but we're going to go ahead and reset the progress. And as you can see, there is a video that Tryhackme has uploaded for this room, but I'm going to go ahead and cover it as I've been doing and iterate through each task. Looks like we have 7 tasks, and it looks like it's a pretty easy room to do. So let's jump in. All right, what is HTTPS? What is HTTP? Hypertext Transfer Protocol. HTTP is what's used whenever you view a website, developed by Tim Berners-Lee and his team between 1989 and 1991. HTTP is the set of rules used for communicating with web servers for the transmitting of web page data, whether that is HTML, images, videos, etc. What is HTTPS? Hypertext Transfer Protocol Secure. HTTPS is the secure version of HTTP. HTTPS data is encrypted, so it not only stops people from seeing the data you are receiving and sending, but it also gives you assurance that you are talking to the correct web server and not something impersonating it. Okay, answer the questions below. What does HTTP stand for? And we have the answer to that right here. Control C, Control V. It's Hypertext Transfer Protocol, but I'm missing the L. Let's submit that. What does the S in HTTPS stand for? And we can see it's for secure. I'll just grab it, throw it in. On the mock web page on the right, there is an issue. Once you find it, click on it. What is the challenge flag? So we're going to go ahead and open up the view site. And it says there is an issue, and what we're talking about is HTTP, HTTPS. So we can see there, this is not secure. We're going to click it, and we get a flag. So grab that. Throw that in. And we can now move to task 2. Task 2, requests and responses. When we access a website, your browser will need to make requests to a web server for assets such as HTML, images, and download the responses. Before that, you need to tell the browser specifically how and where to access the resources. This is where URLs will help. What is a URL? Uniform Resource Locator. If you've used the internet, you've used a URL before. A URL is predominantly an instruction on how to access a resource on the internet. The below image shows what a URL looks like with all of its features. It does not use all features in every request. So we've got a schema, the user, host domain, port, path, query string, and then the fragment. And we're going to go through each of those right now. So a schema. This instructs on what protocol to use for accessing the resource, such as HTTP, HTTPS, FTP, just file transfer protocol. Users. Some services require authentication to log in. You could put a username and a password into the URL to log in. Host. The domain name or IP addresses of the server you wish to access. The port. The port that you are going to connect to, usually 80 for HTTP and 443 for HTTPS. But this can be hosted on any port between 1 and 65,535. Path. The file name or location of the resource you are trying to access. Query string. Extra bits of information that can be sent to the requested path. For example, blog $ID = 1 would tell the blog path that you wish to receive the blog article with the ID of 1. Fragment. This is a reference to a location on the actual page requested. This is commonly used for pages with long content and can have a certain part of the page directly linked to it, so it is viewable to the user as soon as they access the page. And then making a request. It's possible to make a request to a web server with just one line, get HTTP 1.1. And then we have a little graphic here, request method, the HTTP protocol. But for a much richer web experience, you'll need to send other data as well. Let's just scroll up. This other data is sent in what is called headers, where headers contain extra information to give the web server you are communicating with. But we'll need to get more into this in the headers task. Okay, examine the request. So this is a header. To break down each line of the request, line 1, the request is sending the get method. More on this in the HTTP method task. Requesting home page with a / and telling you the web server we are using HTTP protocol version 1.1. So it's right there. And we move on to line 2. We tell the web server we want the website tryhackme.com. Line 3, we tell the web server we are using Firefox version 87 browser. You can see it right here. Line 4, we are telling the web server that the web page that referred us to this one is https://tryhackme.com. And then line 5, HTTP requests always end with a blank line to inform the web server that the request is finished. We've got our example response, a 200 OK. To break down each line of the response, line 1, HTTP 1.1 is the version of the HTTP protocol of the server that the server is using, then followed by the HTTP status code of 200, which is an OK, which tells us that the request has completed successfully. Line 2, this tells us the web server software and version number. So Nginx 1.15.8. The current date, time, and time zone of the web server is on line 3. Line 4 has the content type header, tells the client what sort of information is going to be sent, such as HTML, images, videos, PDF, XML. Okay. Line 5 is the content length, tells the client how long the response is. This way we can confirm no data is missing. Line 6 is the HTTP response, contains a blank line to contain the end of the HTTP request. Okay, so that must just be the blank. And then we've got lines 7 through 14. The information that has been requested, in the instance, the home page. All right, let's answer the questions. What HTTP protocol is being used in the above example? Guess we're talking about this here, HTTP 1.1. What response header tells the browser how much data to expect? Content length. All right, moving on to task 3. HTTP methods. HTTP methods are a way for the client to show their intended action when making an HTTP request. There are a lot of HTTP methods, but we'll cover the most common ones, although mostly you'll deal with get and post method. So we got our GET request. This is used for getting information from a web server. A POST request. This is used for submitting data to the web server and potentially creating new records. A PUT request is used for submitting data to a web server to update information. And then we have the delete request. This is used for deleting information, records from a web server. Answer the questions below. What method would be used to create a new user account? So to create a new user account, we would do a POST request. Just type each of these out. What method would be used to update your email address? We would do a request for that. What method would be used to remove a picture you've uploaded to your account? That's going to be a delete request. And then what method would be used to view a news article. We would send a GET request for that. All right, moving on to task 4. HTTP status codes. In the previous task, you learned when an HTTP server responds, the first line always contains a status code informing the client of the outcome of the request, also potentially how to handle it. These status codes can be broken down into 5 different ranges. So we've got our 100 through 199. We've got our success, redirection, client errors, server errors, and then explanations for each of those. Common HTTP status codes. There are a lot of different HTTP status codes. That's not including the fact that applications can even define their own. You'll go over the most common HTTP responses you are likely to come across. Then we've got our 200s, 300s, 400s, and 500s. So 200 is okay. Request was completed successfully. 201 is created. 301 moved permanently. 302 it's found. 400 is a bad request. 401 not authorized. 403 forbidden. We've got our 405 method not allowed. 404 page not found. 500 internal service error. And then a 503 service unavailable. If you're a visual learner, also check out this great http.cat resource. Let's go ahead and open that in another tab and check it out. Oh, I see. That's interesting. All right. Okay, answer the questions below. What request code might you receive if you've created a new user or blog post article? So if you've created a new user or blog post article, 201 is created. Throw that in. What response code might you receive if you've tried to access a page that doesn't exist? Probably 404. What response code might you receive if the web server cannot access its database and the application crashes? You might get an error. Or you might get a 503. Doesn't say you'd get an error. Let's go with 503. What response code might you receive if you try to edit your profile without logging in first? Oh, not authorized. 401. Put that in. All right, on to task 5. All right, task 5 is headers. Headers are additional bits of data you can send to the web server when making a request. Although no headers are strictly required when making an HTTP request, you'll find it difficult to view a website properly. Common request headers. These are headers that are sent from the client, usually your browser, to the server. We have our host. Some web servers host multiple websites, so by providing the host headers, you can tell which one you require. Otherwise, you'll just receive the default website for the server. The user agent. This is your browser's software and version number. Telling the web server your browser software helps it format the website properly for your browser, and also some elements of HTML, JavaScript, and CSS are only available in certain browsers. Content length. When sending data to a web server such as in a form, the content length tells the web server how much data to expect in the web request. This way the server can ensure it isn't missing any data. Accept encoding tells the web server what types of compression methods the browser supports so the data can be made smaller for transmitting over the internet. And then cookie. Data sent to the server to help remember your information. Set cookies task for more information, or see cookies task for more information. So it's probably going to be something down here somewhere. All right, common response headers. These are the headers that are returned to the client from the server after a request. So you got set cookie, cache control, content type, and content encoding. We'll go over them each. Set cookie. Information to store, which gets back to the web server on each request. See cookie task for more information. We've seen that a couple times now. Cache control. How long to store the content of the response in the browser's cache before it requests it again. Content type. This tells the client what type of data is being returned, i.e. HTML, CSS, JavaScript, images, PDF, video, etc. Using the content type header, the browser then knows how to process the data. Then we have content encoding. What method has been used to compare the data to make it smaller when sending it over the internet? Answer the questions below. What header tells the web server what browser is being used? That's going to be content user agent, actually. User agent? Right? Okay. What header tells the browser what type of data is being returned? What type of data? Content type. What type of data? Control C, Control V, wrote in. What header tells the web server which website is being requested? Post. Throw that in and check it. Task 5 is done. We are now on to task 6. Cookies. You've probably heard of cookies before. They're just a small piece of data that is stored on your computer. Cookies are saved when you receive a set cookie header from a web server. Then every further request you make, you'll send the cookie data back to the web server. Because HTTP is a stateless, doesn't keep track of your previous requests, cookies can be used to remind the web server who you are, some personal settings for the website, or whether you've been to the website before. Let's take a look at this in an example HTTP request. So this graphic has an example HTTP request in it. And we can see the cookie information being passed through. Cookies can be used for many purposes, but are most commonly used for website authentication. The cookie's value won't usually be a clear text string where you can see the password, but rather a token, unique secret code that isn't easily humanly guessable. Viewing your cookies. You can easily view your cookies. You can easily view what cookies your browser is sending to a website by using developer tools. In your browser, if you're not sure how to get to the developer tools in your browser, click on the View Site button at the top of the task for how-to guide. So we just go here. I'm using Firefox, but it has all these different ways to walk you through it. So we'll just follow along, click here. We want more tools, and then we want the web developer tools. And once you have the developer tools open, click on the network tab. This is the tab that will show you a list of resources your browser has requested. I think we'll probably need to refresh the page, but let's continue reading. A list of resources your browser has requested. You can click on each one to receive a detailed breakdown of the request and response. If your browser sent a cookie, you will see these on the cookies tab of the request. So which header is used to save cookies to your computer? What was that? I think it set it up. Set cookie right here. Okay. I'll just type it out. Set cookie. And we're on to task 7. Click the View Site button on the right. This is an emulator for making demo HTTP requests. Using what you've learned from the above tasks, you can use it to complete the below questions. Let's open up our site. And we have a tour guide. We like a tour guide. I'm going to skip it. Make a GET request to the room page, which should just be, oh, we want to go to /room. And let's just go. And here's our response, and we've got a flag. Control C, Control V. And there's a hint. Yeah, okay, we already know that. Check it. Make a GET request to the blog page and set the ID parameter to 1. Use the gear button. Okay, so it kind of walks us through, but essentially what that's telling us is to set this to blog. We want to make a GET request. We want to click the gear icon. And we want to set ID to 1. I think. Save it. And send it. Okay, we got our next flag. And we can see how that looks in the browser as well. Make a delete request to user1 on the page. So to do this, I think we want to go to user and then click the wheel or the icon, and we want to set this to, I might be doing this wrong. Let's just try it though. User1, save it. That doesn't look right to me. Can't find. How am I doing this? Make a delete request to user1 page. Oh, I know what I did wrong. So user1, overthinking it. Go. There we go. All right. Got the flag. Now we want to make a put request to user2. All right, so we're going to do put. Drop this down to a put. With the username parameter set to admin. Note, use the gear button on the right to manage body parameters. Okay, what's the hint tell us? Click on the settings cog to add a parameter to put to the put request. So we're just going to open this up. We want to do username admin, I believe, for this. Save it. And let's hit go. Okay, THM user has been updated. Username changed to admin. Okay, let's grab it, throw it in. All right, and the last question here. Make a post request to login page with the username of THM and a password of let me in. No, use the gear button. Okay, we already know that. What's our hint say? Delete the parameter request from the previous task. Oh, so that's telling us we need to go in. All right, let's set ourselves up first. So we want to go to the login page. We're doing a post request. I want to hit the wheel and we want to remove. Did I do that right? I don't know if I did that right. Add a parameter. So we want username, THM. We were not done. What? Okay, so save wasn't what I wanted to hit. Add param was. And we want password. Let me in. That looks right. Let's save that and let's send it. And we get our final flag. You are logged in. Welcome back. Let's grab it, throw it in. It looks like I completed a weekly mission. I get 20% XP for the next 3 hours. And I've completed HTTP in detail. So what is our next room? It's telling me to get in there right now and get the bonus XP. Demonstrate your expertise. You've earned a new badge. All right, continue learning. And in the next video, we will jump into OWASP Juice Shop. I hope you enjoyed this one. Thank you for watching.